All right, what I'm going to talk about is factoring polynomials. You will see me following this rule, this document, okay? I'm going to do most of this document. I'm going to do it more slowly than I would normally do it in a regular college algebra class. The steps are going to be on the paper. I'm not going to list the steps. You'll read the steps. And I will do the examples here on the board. Okay? Example 1. I have 18x to the 4th y cubed plus 12x cubed yz minus 24 x squared y cubed. Okay? Now, to find the greatest common factor, what you do is you find the highest number that divides all three terms. These three terms are divisible by 2, by 3, and by 6. Okay? So the GCF is 6. All three terms have an x in them. And between x to the 4th, x cubed, and x squared is the lowest appearing power. They all three have y's in them. Between y cubed, y to the 1st, and y cubed, y to the 1st is the lowest appearing power. So we'll have 6x squared y, and we simply divide. 18 divided by 6 is 3. We'll subtract exponents. X to the 4th divided by x squared is x squared. Y cubed divided by y to the 1st is also y squared. Okay? 12 divided by 6 is 2. X cubed divided by x squared will leave you x to the 1st. The y's cancel. Y divided by y is 1, and 1 times 2x is 2x. The z is unaffected. Okay, and then negative 24 divided by 6 is minus 4. The x squareds cancel is 1, and 1 times minus 4 is minus 4. The x squareds cancel. Y cubed divided by y to the 1st is just y squared. Okay? Example 2. 10ab plus 15bc plus 5c. Okay? 5 divides all three terms. Now, A only appears in the first term, B appears in 2 terms, but not 3. C appears in 2 terms, but not all 3. So the greatest common factor is 5. And 5 only. So I'm dividing everything by 5. 2ab plus 3bc plus 5c divided by 5 is 1c, which is just c. Okay? Example 3. 10x cubed y squared minus 12xy plus 15x. Okay, now folks, these two terms are divisible by 2, but 15 is not. 12 and 15 are divisible by 3, but 10 is not. And these two are divisible by 5, but 12 is not. So no number divides, other than 1, divides all 3. They all have x's in them. And that's all they have. Between x cubed, x, and x, the lowest appearing power is x. So all the powers of x will go down 1. 10x squared, y squared, minus 12. The x's cancel, leaving 12y. And then the x's cancel here as well. Okay, so we'll have 10x squared, y squared, minus 12y plus 15. Okay? Example 4 has something very important going on here. Okay, I'm going to move it down. Example 4, I have 2x cubed minus 6xy plus 2x. Okay, all three of them are divisible by 2. The lowest appearing power of x between x cubed, x, and x is x to the first. So 2x cubed divided by 2x, the 2's cancel, leaving 1. 1 times x cubed divided by x is x squared. Minus 6 divided by 2 is minus 3. The x's cancel, leaving 1. And then you have your y. Okay, I don't need to write the 1 because I had other factors, other values here. Now here the 2x's will cancel completely. So 2x divided by 2x is 1. That's important. You can't leave it blank if it cancels. You have to leave. If you had 3 terms, you need to finish with 3 terms. Okay? And then finally I have example 5. X cubed plus 6x squared. They both have x squareds. They both have an x in them. And the lowest appearing power of x squared, the lowest appearing power of x is x squared. All right, so x cubed divided by x squared is x. 6x squared divided by x squared is just 6. All right, and I am going to move on to grouping. Okay, I've now moving on to factoring by grouping. The steps are on page 2. Now, before you do anything with this, you first need to make sure that you need to make sure the polynomials are in descending order. That means the powers of x should be dropping from left to right. So the powers of x or the powers of your variable. So this is 3, 2, 1, nothing. That's in descending order. This is the powers of x here are 5, 3, 2, nothing. That's also in descending order. If it's not in descending order, you need to rearrange the terms, so it is. All right, now, the most basic method for this, I'm going to be showing you 2 methods for this, a simple and a more advanced. The more simple method is to just, you're always doing these 2 at a time, always doing them 2 at a time, okay? But 2 at a time. Now, the most basic method is to just do these 2 and ignore this. So these 2 are divisible by 5. And they both have an x squared in them. Lowest appearing power between the 2 of them is x squared. 5x cubed divided by 5x squared is just x. 10 divided by 5 is 2, and the x squareds cancel. Okay? And then I'm going to leave this alone. Okay, so these 2 are done. The third term is positive, so you'll take a plus. These 2 are also divisible by 3, so I'll take out a 3. 3x divided by 3 is x, 6 divided by 3 is 2. Okay? So, you should get duplicate binomials. If these are not duplicates, you either made a mistake, or it's not factorable by grouping, or both. Okay? So, let me write this more neatly. One binomial factor is going to be your outside common factors. The other is going to be the binomial that you see twice. Now, a more advanced method to this would be to do both factorizations together. All right? So these 2 are divisible by 5. They both have an x squared in them. So 5x cubed divided by 5x squared is x, 10 divided by 5 is 2, and the x squareds cancel. And then I would take out the plus. These 2 are divisible by 3. 3x divided by 3 is x, 6 divided by 3 is 2. So I would have 5x squared plus 3, and the x plus 2. All right. Over here, it's in descending order because the powers of x are 5, 3, 2, nothing. All right? Now, these 2 terms are divisible by 7. The lowest appearing power between the 2 of them is an x cubed. So 14 divided by 7 is 2. The x to the 5th divided by x cubed is x squared. 35 divided by 7 is 5. The x cubes cancel. Okay? All right, so if I'm following the basic method, I only did this when I left these two alone. Now, you have to factor something out. So, in the absence of anything else, the only thing that divides these two is 1. So, division by 1 changes nothing. So you will have 7x cubed plus 1 times 2x plus 5. Or you could have done this all at once. 14x to the 5th plus 35x cubed plus 2x squared plus 5. So what I could have done is these two are both divisible by 7. They both have an x cubed in them. So 14 divided by 7 is 2x to the 5th divided by x cubed is x squared. Okay? And 35 divided by 7 is 5. And the x squareds cancel. All right, so now I have a plus. These two are divisible by 1 and nothing else. Division by 1 changes nothing. So, 7x cubed plus 1 and 2x squared plus 5. All right. I'm going to go ahead and erase example 1 and leave example 2 on the board. That way you can do this by comparison. Example 3 is x cubed minus 19x squared minus 2x minus 38. Okay? They both have an x squared in them. Actually, I'm sorry, this should be plus. Pardon me. All right, so these two have an x squared in them. X cubed divided by x squared is x. 19x squared divided by x squared is 19. If I'm doing the basic method, I'm ignoring those two for now. All right, now if the third term is negative, you're taking out a negative. They're both even, so I'll take out the 2. Now dividing by a negative changes the signs. So negative 2x divided by negative 2 is positive x. Negative 38 divided by negative 2 is positive 19. So x squared minus 2 times x plus 19. Or I could have done the two factorizations together. Okay? So sorry. All right, so I'll make sure that's dark enough. Okay, these two are divisible by x squared. X cubed divided by x squared is x. 19x squared divided by x squared is 19. Third term is negative. They both have a 2. They're both even, so they're both divisible by 2. Negative 2x divided by negative 2 is x. Negative 38 divided by negative 2 is plus 19. So you end up with x squared minus 2 and x plus 19. Notice that dividing by a negative changes both signs. So this was negative, negative. Now it's positive, positive in parentheses. I'm going to get example 2 off the board and move on to example 4. So I have 3x squared y minus 6xy minus 14x plus 28. Now I want to make sure they're in descending order. So I'm thinking, because this is a multi-termer, I'm thinking degrees. Okay? That's the sum of the exponents in the term. So the degree of this term is 2 plus 1, which is 3. Degree here is 3. Degree here is 2 because of 1 plus 1. Degree here is 1. And this one has a degree of 0 or no degree. So it's in ascending order. Now these two are divisible by 3. They both have an x in them. They both have a y in them. 3x squared, the 3's cancel, and I put 1 if nothing else survives, but x squared divided by x is x. The y's cancel. Negative 6 divided by 3 is minus 2. The x, y's cancel. Okay, so these two are done. The third term is negative. Okay? These two are divisible by 7 and by 14. So I'll take the 14. Negative 14x divided by negative 14 will be positive x. And 28 divided by negative 14 is minus 2. Okay? So I will now have 3xy minus 14 times x minus 2. Okay? That is the final version in factored form. Alternatively, you could have done the factoring at the same time. So I'd have 3x squared y minus 6xy minus 14x plus 28. Okay? I could have taken the 3xy out of both terms, giving me x minus 2. The third term was negative, so I would have taken out a negative. They're both divisible by 14. Negative 14x divided by negative 14 is just x. And then 28 divided by negative 14 is minus 2. So I'd have had 3xy minus 14 and x minus 2. Okay, I'm going to pause here and switch methods and put examples 5 and 6 on the board. All right, here at examples 5 and 6, I'm going to start with the more advanced method and then go on to the and then show the more basic method for comparison purposes. So these two both have an x to the 5th in them. X to the 8th divided by x to the 5th is x cubed. And the x to the 5ths cancel here, leaving you negative 17. Okay? Third term is negative. They're both divisible by 2 and 4. I'll take out the 4. And I'll be dividing by negative 4. So that'll be positive x cubed and minus 17. So I will have x to the 5th minus 4 and x cubed minus 17. Or what I could have done is x to the 8th minus 17x to the 5th minus 4x cubed plus 68. What I could have done instead is I could have done these two together and ignored that, so just these two. That would have left me x cubed minus 17. So these two are done. And what I could have done here is I could have taken the negative out. They both have a 4 in them. They're both divisible by 4. And then I would have had x cubed, positive x cubed, and 68 divided by negative 4 is negative 17 again. So I would have had x to the 5th minus 4 times x cubed minus 17. Okay? All right, over here. First you have to get this in descending order. So I can't start with this. It's not in descending order. Hold on, I dropped something. All right, so you got to get it in descending order first because the powers of x are 1, 4, 3, and nothing. So I'll put 63x to the 4th first, then the minus 9x cubed, and then plus 56x, and then minus 8. Okay? Under the more advanced method, I would notice that these two are divisible by 9. Okay? And they both have an x cubed in them. They're divisible by 9, and they have an x cubed in them. Okay, so 63 divided by 9 is 7. X to the 4th divided by x cubed is x. All right, now notice here that this cancels, these are the same. So they would cancel as 1. These two terms are divisible by 2, 4, and 8. Take out the 8. So 56x divided by 8 is 7x. And negative 8 divided by 8 is minus 1. So we will have 9x cubed plus 8 times 7x minus 1. Alternatively, here's what the basic method would have had it looking like. 63 x to the 4th minus 9x cubed plus 56x minus 8. It's always got to be in descending order. Okay, descending order, descending order, descending order. All right. So I would have taken a 9 out of those two terms and the x cubed out of both terms. So 63 divided by 9 is 7. X to the 4th divided by x cubed is x. And then these would have canceled completely, leaving you minus 1. You would have left these two alone if you were using a more basic method. So these two are done. These two are divisible by 8. I would have taken it out. And then 56x divided by 8 is 7x. And then minus 8 divided by 8 is minus 1. So I would have had 9x cubed plus 8 times 7x minus 1. All right. All right. On page 3, you have the steps for basic x squared trinomials. Okay? What you would do is you start with x and x. Now, what you're looking for is you're looking for the pair of factors of 24 to 11. Pair of factors of 24 with some positive 11. Okay? If you know right away, you can just go with it. Okay? So, let's say I have no idea. Propose sum. So I could do 1 and 24, that's 25. I could do 2 and 12. That's a pair of factors of 24. That adds up to 14. These are no, these are no. But 3 and 8 does the job. 3 and 8 is 11. So you could do x plus 3 and x plus 8. Okay, because those would be the second terms. Okay? Alternatively, you could do the other word. Or x plus 8, x plus 11. I'm sorry, x plus 3. Now, folks, you don't have to do this. If you can recognize that it has to be 3 and 8 right away, you could skip from here straight down to there. Okay? All right. This is a problem that's designed to get more advanced students to think through the process. Most of your problems will not be this difficult. So I'm starting with x and x. I need the pair of factors. There's only one of negative 80 with sum that equals positive 11 again. Okay? I'm going to pretend that I have no idea. Propose and sum. Okay? So I know it's even. I know it's an integer, so it's divisible by 1. Negative 80 divided by 1 is negative 80. And 1 plus negative 80 would give me negative 79. That's neither the positive nor negative version of what we need. We need 11. It's even. Let's try 2. So, negative 80 divided by 2 gives me negative 40. I still have negative 40 on my calculator. I'll go ahead and add 2. Add the 2 back. I got negative 38. That's neither plus nor minus 11. So now I know 3 doesn't divide it. If I tried 3, it wouldn't divide evenly. I know I'll try 4. 4 and negative 20. So 4 plus negative 20 is negative 16. That's a no. If the last digit is 0 or 5, it's divisible by 5. We'll try 5. So negative 80 divided by 5 is negative 16. That's negative 11. That's the opposite of what we need. So what we're going to do is change the signs. Negative 5, positive 16. That's 11. That is exactly what we need. So I will have x minus 5 and x plus 16 in either order. Okay? Now, here's some things that if you need, ideally you won't need to guess, but if you do need to try an error, here's some patterns to be aware of with numbers. This has to be, the last term is always a product of 2 numbers. You multiply 2 numbers to get this. The only way you can get a positive from multiplying 2 numbers is if both are positive. The only way you can get both positive or both negative. They have to be both positive or both negative. And if the sum is positive, they both have to be positive. Now, if the product is negative, then that means one's negative, one's positive. But if the sum is positive, that means if the sum is positive, that means the gain, the positive, outweighed the minus. Okay? X squared minus 2x minus 15. Okay? I got x and x. Let's say I need the pair of factors of negative 15 with sum equaling negative 2. Okay? Well, the only pair of factors we could do a proposed sum pair, but what I'm going to do is I'm going to say it has to be negative 5 and positive 3. If we multiply these, we get negative 15. If we add them, we get negative 2. So that would be x minus 5, x plus 3. Or, if you can't see it right away, you could do x squared minus 2x minus 15. So we'll start with x and x. Pair of factors of negative 15 with a sum of 3, or sum of negative 2. Sum of negative 2. All right, I'm going to pretend that I don't know. Propose sum. All right, it's even. I'm sorry, it's not even. It's an integer, so we'll try 1. Negative 15 divided by 1 is negative 15. We get negative 14. That's not what we need. Now, it's not even, so we know 2 doesn't do it, but 3 does. So that was a no, that was a yes. So we have x plus 3, x minus 5. Okay? Again, you don't need to do the table if you know it, if you recognize the pair of factors right away. Okay, now let me compare these two problems. All right? Here, the product is always the product for these two is negative. Okay, both of these products were negative. So one factor was positive, one was negative. Okay, but so one was positive, one was negative. But if the sum is positive, the positive outweighs the negative. If the sum is negative, the negative outweighs the positive. All right. So next I propose to skip example 3 and do example 4. Okay, with example 4, I have x squared minus 9x plus 20. Okay? So x and x, pair of factors of 20 with sum. Okay, I'm going to put that. I'm going to rewrite that more neatly. Of 20 with sum equaling negative 9. All right? Well, when I think factors of 20 that have a relationship with 9, I normally think 4 and 9. Okay? But this has to be positive 20, and the sum has to be negative 9. So that's going to be negative 5, negative 4. So x minus 5, x minus 4. Okay? Or alternatively, you could use the table. You can always use the table. Okay? You can always use a table, but you don't always have to use a table. Further, you don't have to spell this out every time. Okay? Or what you could do is you could say if x squared minus 9x plus 20. If you're asked to factor that, what you could do is x minus 4 and minus 5. You could go straight to the factoring stages. Okay? You can always do that. All right, I'm going to pause here and clear the board. All right, so let me switch on over to example 5 and example 6. Okay? Note that y is equivalent to plus 1y. Okay, that is what I have, right? Yes, it is. Okay, so y is equivalent to plus 1y. So I'm going to be setting up y and y, and I need the pair of factors of negative 12 that have the positive 1. Okay? Pair. So I'll go ahead and put that down there. Pair of factors of negative 12 with a sum equaling positive 1. Okay. The answer is 4 and negative 3. Okay? So I would have y plus 4 and y minus 3. Okay? Because that's the pair of factors of negative 12 that add up to 1. Okay? And you don't need to write this thing out if you choose not to. All right? Likewise, we're going to do A and A. I'm looking for the pair of factors of 225 that add up to 30. Factors of 225 with a sum equaling 30. Answer? 225 is 15 squared. 225 is a perfect square. It factors as 15 squared as one option. So 15 and 15. So you would have a plus 15 and a plus 15. Okay, that can happen. All right, finally, some trinomials are prime. This means they cannot be factored. So for instance, example, x squared plus 3x plus 22. Okay? No pair of factors of 22 has a sum 3. Okay? So this is prime. Not factorable. Or non-factorable, one word. Any one of these descriptions would describe this polynomial, because the only pairs of factors of 22 are 1 and 22, which the sum is 23, and 11 and 2 is 13. Okay? Factors of 22 are, you got 1, 22, with that gives you a sum of 23, and you have 2 and 11. The sum is 13. None of them are 3. None are 3. Okay? All right, so that's prime because there is no pair of factors of this that add up to that. All right, I'm going to pause here. I'm going to stop here and go on to the next step. All right, I'm going to start with 3x squared minus 10x minus 8. Now notice that 3 is not a common factor of this. Okay, so what I'm going to have to do is I'm using an unconventional method. The steps are on page 5. I would start with ax and ax. That would be 3x and 3x. So 3x and 3x. Note, they're not both going to stay. One of them is going to be gone. One or both will be gone. Okay, actually, one will be gone. So, what I'm going to do is I'll start with 3x and 3x. Second step is to take the first number you see times the constant, the quadratic coefficient times the constant. That gives me negative 24. Okay? I need a pair of factors. Of negative 24 with sum that equals negative 10. All right, if you don't know, right off the top of your head, go ahead and use a proposed sum table. Proposed sum. First of all, I recommend starting with the pair that gave it to you to begin with. So that would be 3 and negative 8. I got negative 5. That's neither plus nor minus what we need. So, no. Okay? Because we need the sum to be negative 10. All right, well, any integer is divisible by 1. So negative 24 divided by 1 is negative 24. The sum is negative 23. No. Okay? Well, it's even. Let's try 2. And negative 24 divided by 2 is negative 12. That's negative 10. That is what we need. Okay? So I'll make those my second terms. Now this is very important. Okay? You look for anything that divides both terms of any binomial. These two are divisible by 1 and 1 only. But these two are divisible by 3. So divide by 3. Okay? So I will have 3x plus 2 and x minus 4. Because that's division. And I'm finished. Okay? Example 2. What was it? Example 2, I had 10x squared minus 27x plus 5. All right? So, I will have 10x and 10x. And again, if that was to this was to survive, that'd be 100x squared, and that's not what's going to happen. One or both are going to be gone. All right, next I'll take 10 times 5, and I will get 50. I need a pair of factors, the pair of factors of 50 with a sum of negative 27. All right, so I'll start with the pair that gave it to me. Propose and sum. The pair that gave it to me was 10 and 5. That's 15. Or that's not what we need. Okay? No. Because we need negative 27. Well, it's an integer. Let's try 1 and 50. That's 51. No. Okay? If we get the opposite of what we need, we change the signs. If we get the opposite of what we need, we change the signs. Okay? But we don't need to. Okay? So now I'll try 2 and 25, and I get 27. That's the opposite of what I need, because I need negative 27. So now we'll do negative 2 and negative 25, and that's negative 27. That is what we need. So now I will have 10x minus 2 and 10x minus 25. Okay? Now, again, we will always check to be sure. We'll check every one of these to be sure that both terms have something that divides them besides 1. These two are divisible by 2. They're both evens. They're divisible by 2. These two are divisible by 5. Let me make that. Let me spread those dots around so that it doesn't look like a plus. These two are divisible by 5. So 10x divided by 2 is 5x. Minus 2 divided by 2 is minus 1. And then 10x divided by 5 is 2x. And negative 25 divided by 5 is minus 5. All right. So with this one, for example 1 of the binomials canceled. Just one of them. But on this one, they both canceled. They both had a division. Okay? So let's put up example 3. Example 3. I think I'm going to move it over. Example 3. (6x squared plus 17x minus 3). All right, so we'll start with 6x and 6x. And 6 times negative 3 is negative 18. Pair of factors of negative 18 with a sum that equals positive 17. All right, if you, again, you may not need the table, okay? Answer, 18 and or negative 1 and 18. Negative 1 and positive 18. All right? So, we have 6x minus 1 and 6x plus 18. All right? And these two are divisible by 6, leaving me 6x minus 1 and x plus 3. All right, now let's suppose I choose to do this. So this time only one of the binomials had a common divisor. Okay? I'm going to do example 3 again. Example 3 longer. So I'll have 6x squared. Have to move it down. 6x squared plus 17x minus 3. Okay? Let's say you didn't see this right away. Well, we'd still have 6x, 6x. All right? And then I would take 6 times negative 3. I get negative 18. I need a pair of factors of negative 18 with a sum that equals positive 17. This time I'm going to do a propose and sum pair. Okay? Well, I could try the pair that gave it to me, 6 and negative 3, and I get 3. No. Okay? If it was negative 3, if this was negative 3, I would just change the signs, but it's neither positive or negative what we need. Okay? We need 17, not 3. All right? Well, let's try 1, because it's an integer, it's divisible by 1. 1 negative 18 would give me negative 17. That's the opposite of what I need. So, negative 1 positive 18 is 17. That's what we need. So x minus 1, I'm sorry, 6x minus 1 and 6x plus 18. No common factor besides 1. Common factor is 6. So, 6x minus 1 and x plus 3. Okay, same as before. All right. Example 4. We will have 8x squared plus 15x plus 7. All right, so we have 8x and 8x, and then I'll take 8 times 7, and I get 56. Pair of factors of 56 with a sum that equals 15. 8 and 7. Or 7 and 8. So, we would have 8x plus 7 and 8x plus 8. Okay? Let me try to make, I'm going to make the 8s more exaggerated for the camera. Or try to. 8x plus 7, and 8x plus 8. All right. And this has no common factor besides 1, but this one has 8. So we end up with 8x plus 7 and x plus 1. All right. Or we could do example 4 longer. So example 4, longer. I would have 8x plus 8x squared plus 15x all right. I would start with 8x and 8x. 8 times 7 is 56. Pair of factors. Of 56 with a sum that equals 15. Let's say I don't know. So propose and sum. Again, as I said, the first thing you should try is the pair that gave it to you. 8 times 7 is 56. 8 and 7. Okay. First pair of factors that gave you 56 was 8 and 7, and the sum is 15. That's what you need. Okay? So we'll have 8x, so we would do 8x plus 8 and 8x plus 7. And I would divide these two by 8. So that's going to be x plus 1 and 8x plus 7. All right, I'm going to stop here and move on to the next topic. Okay, I am skipping page 7 and going on to page 8. Okay, page 7 was an alternate method to the trinomials that I was doing earlier. I'm moving on to something called difference of squares. Difference of squares is where you have a perfect square minus a perfect square. It has to be a minus. Okay? So for instance, I know this is a perfect square because the coefficient is a perfect square 4, has a square root 2, and a square root which is 2, and that's an even exponent. Likewise, that's a perfect square. And again, there has to be a minus in the middle. You can skip this step if you can do it in your head. Just take the square roots. Okay? The square root of 4x squared. Square root of 4 is 2. Square root of x squared is x. Square root of 9 is 3. So I would have 2x plus 3 and 2x minus 3. Okay? Square root plus square root, square root plus square root minus square root. Okay? Example 2. Alternatively, what you could have done, is you simply could have put up a pair of parentheses. Square root of 4x squared is 2x. Square root of 9 is 3. Put a plus in one and a minus in the other. Okay, that's what you could have done. Example 2. You have to put it lower because according to my camera I got a glare. Example 2. What does it say? X to the 6th minus 25y squared. Alright, so what you're going to do is square root of x to the 6th, you'll cut the exponent in half, you get x cubed. Okay? The square root of 25y squared, square root of 25 is 5, square root of y squared is y. So you'll have x cubed plus 5y and x cubed minus 5y. Okay? Example 3, x squared minus 441. Okay? Do. Well, you could do this in your head, but the square root of 441 is 21. Okay? So I'll have square root of x squared is x. Square root of 441 is 21. So plus 21 minus 21. Okay? Note. Okay? Sum of squares is prime. Okay? So 4x squared, so by comparison 4x squared plus 9 is prime. So 4x squared plus 9 would be prime. Not minus 9 factors like this. Okay? But plus 9 is prime. Okay? Similarly, x squared plus 441 is also prime. Okay? So, compare. X squared minus 4,900, well, x squared minus 4,900, square root of x squared is x, square root of 4,900 is 70. So plus 70 minus 70. But x squared plus 4,900 is prime. Okay? Non-factorable. Okay? All right, so that's difference of squares. Please note the difference. Difference of squares, where you have something squared minus something squared, is factorable. But sum of squares, something squared plus something squared, is prime. All right, so at this point, I'm going to stop this video and move on. All right, at this point, I'm going to talk about sums and differences of cubes. Okay? I'm going to do example 1 exactly like I have it on the paper. I'm going to replace example 2 with this. Okay? These a's and b's represent your cube roots. So a would be the cube root of x cubed. If you can do that in your head, that's fine. You don't have to do this step. You can do it in your head. B would be the cube root of 8. Okay, and that's what B would be. Okay, the cube root of 8 is 2. So folks, if the rule is a cubed plus b cubed, if it's a sum of cubes, you would follow the rule a plus b times a squared minus ab plus b squared. All right? So a you would replace with x, b you would replace with 2. I recommend making the trinomial parentheses a bit taller the first time you plug these things in. So a will be replaced with x squared minus a is again x, b is 2. And then plus 2 squared, still in parentheses. All right? And this will not be changing. This will be x plus 2. You can shorten these now. Okay? x squared is x squared minus 2x, and then 2 squared is 4. And that's it. At this point, you're finished. All right. On this one, it's a little bit more complicated. A will be my cube roots again. So A is the cube root of 1000x cubed. All right, which is just the cube root of 1000 is 10. The cube root of x cubed is x. B is the cube root of 729, which is 9. All right? So, since it's the difference of cubes, it follows this rule. A minus B times A squared plus AB plus B squared. All right, so A will be replaced by 10x. B will be replaced by 9. I make my trinomials a little taller. A is 10x, I'll put it in parentheses. Make this pair of parentheses a little taller too. Plus 10x times 9. Okay, plus 9 squared, all in a taller pair of parentheses. Okay? All right, now over here, this will be 10x minus 9. And then 10x squared, folks, 10x times 10x is 100x squared. Okay? That's going to be plus 90x plus 81. All right. All right, on pages 12 and 13, I will be focusing on multi-step factoring. Now, on page 12, you might notice 3x squared minus 3x minus 36, and it might remind you of a similar looking problem we did on page 5. Okay? The difference between this one and this one is that here, 3 was not a common factor. Here, 3 is a common factor. Okay? Since 3 wasn't a common factor, we had to do this. Okay? But for this one, the 3 is a common factor, so I will take out that 3. So I'll divide everything by 3, and I end up with x squared. 3x squared divided by 3 was x squared, minus 3x divided by 3 was minus x. Negative 36 divided by 3 was negative 12. Okay? Now, the next thing I would look for, because this is an x squared trinomial, I would see if I could come up with a pair of factors of negative 12 that to negative 1. And I can. Okay? The pair of factors of negative 12 out to negative 1 are negative 4 and positive 3. Okay? So now I'm done with this polynomial. You have to keep factoring until every polynomial is prime. Binomial, trinomial, whatever, it has to be prime when you're finished. Okay, example 2. I have 4x squared minus 36. Okay? I don't like how it looks on my computer screen, so I'm going to exaggerate. Try to make it look more notable. Now, some of you might be thinking difference of squares. 2x plus 6, 2x minus 6. But before you do that, always take out the common factor 4. Okay? That gives me x squared minus 9. All right, now that also is a difference of squares. That's x squared minus 3 squared. So I'll keep the 4, and I'll have square root of x squared is x, square root of minus 3, plus in one and minus in the other. Okay? All right, example 3. Actually, I'm going to move it up. Example 3, I had 2x cubed plus 20x squared plus 50x. All right. Well, they're all 3 even, so I'll take out a 2. They all have x's in them. And the lowest appearing power of x was x to the first. So 2x cubed divided by 2x is x squared. 20x squared divided by 2x will be 10x. And 50 divided by 2 is 25, and the x's cancel. Now, before I assume I'm done, I need to find I need to see if there's a pair of factors of 25 that add up to 10. And there is. 5 and 5. 5 and 5 are pairs of factors of 25 that add up to 10. So I have 2x, x, x. The pair of factors of 25 that add up to 10 are 5 and 5. All right. Okay. And then finally, I'm going to do one example from page 13. Example 4. X cubed plus 10x squared minus 4x minus 40. Now, folks, this has no common factor, but it's factorable by grouping. Okay? This is 10 times, the 10 is 10 times the 1, and that's 10 times that. Okay? So, I'll take an x squared out of this term, these two terms. We have taken x squared out, and x squared cubed divided by x squared is x. 10x squared divided by x squared is 10. Third term is negative. They're both divisible by 4. Negative 4x divided by negative 4 is x. Negative 4 divided by negative 4 is positive 10 again. Okay? So, I end up with, for these two, I end up with x squared minus 4 and x plus 10. But unlike what we had earlier, we're not done, because that's not prime. That's a difference of squares. It's 2 squared minus 2 squared. So because it's a difference of squares, the x plus 10 is unaffected. But the square root of x squared is x. Square root of 4 is 2. Plus 2 minus 2. Now I'm finished. Okay? And this is the end of the video.